All right, so let's dig in. Sorry and my bad are the same thing, right? For the most part, colloquially, we agree? Yeah, not when you're at the funeral. A cheap joke, but still, I mean, another example of that, few of the things that we already know, great minds think alike, and few other phrases that we use commonly, right? But there's another part to it that I've never known for a long, long time. And this kind of changes what they mean, right? Especially the second one, jack of all trades, master of none, but better than a master of one. Now it puts it in a positive context, right? So the thing that I'm getting at is context is really important, especially when you're thinking about logging and you're thinking about observability. Context makes a lot of difference in what you're trying to do, right? So this whole talk is going to be about how you present context in something that is ephemeral as containers, and not just containers as in the Docker container part of it, but then when you take it on to container orchestration systems like Kubernetes as well, how do you ensure that there is context around what you're logging? And logging can be everything that your application is logging. I mean, we've talked about events that Aaron alluded to, but it could be also traces. It could also be some metrics that you're putting in, and all those kind of things. But context is something that you would want to tag on to every single event that is being generated, so that you know when you use those logs, you know the context behind them, right? So let's dig in. There's a lot in there, and I want to sit on this slide for a while, so stop me wherever you want. One of the things that I want to dig into is the Docker aspects of this. Docker kind of did lightning in a bottle, right? When they came up with this product. Even before that, we were using all sorts of things like the BSD jails and LXC and stuff like that, but it was for almost, you had to have a PhD in order to use containers within your operating systems. But Docker made it really accessible. And along with that, Docker actually made it really mature in order to how your applications would log things and use all the other functions along with them as well. They have a very mature logging driver. They give you different ways of capturing your logs. So if your application is logging to standard out and standard error, all you would have to do is put in a logging driver, configure it like you see over here, and all it's saying is take the standard out and standard error, put it into a JSON file, and these are the options in there so that you can plan for the storage capacity as well when it comes to that. And that's something that is important, because all the logs that are being generated out of your containers are now written to disk, so ensure that there's enough capacity on that disk that you can write into. They're also kind of a pain to go through. If you put it onto the same machine and not ship them somewhere else, they do provide logging drivers to do the log shipping as well, but then if you're using something something like a JSON file, you want to ensure that you're shipping it to a centralized location so that you can do stuff on it, aggregate things from all the different containers, different parts of your application, and then do some sort of troubleshooting on that, right? So when we look at the logging to the files, this is something that we want to do, especially in the container world. This is still something that is reasonably easy to achieve. This is very accessible to do, especially when you're writing, you have existing applications. These are applications that you've written in Java. They use some log4j for say, or slf4j. All you would have to do is, instead of writing to its own file, just tell it to write it to standard out and standard error, and it would start working. And if you're a Python programmer, you could use a module for that. If you're a .NET programmer, I'm sure there's modules for that as well. I'm not a .NET programmer. But then if you use Node.js, there's Morgan and logging frameworks like that. And if you're a Go programmer, I don't think they would be listening to this talk, because they're above everyone else, or at least they think they are, right? And so all of these kind of things, once you start logging, you would find that whatever you do in a container world, you can also do, whatever you do in an application sense, you could also do in a container sense as well, because your application is running in a container. Make it simple, write it to a standard out and standard error. But then once you get into orchestration, now you're not just running on one single machine. You're spreading your containers across multiple nodes, multiple worker hosts, or things like that. And what do you do in that case, right? So this is also something that is very mature, even starting from the versions that I was engaged in was 1.4 of Kubernetes. Even at that level, there was a way that kubelet, what it does is it creates a symbolic link to all your Docker logs that are sitting in individual folders on your machines and puts it onto a single folder on your host. And one of the things to make note of here, though, is this is only applicable as long as you're using the JSON driver of Docker. And right now, Kubernetes uses different other Kubernetes runtime engines as well. So if you're using Cryo or if you're using Containerd, you can still do that, and it is still supported out of the box. Another thing, logs are usually stored in the var log. So var log containers is where you would see all the symbolic links to the log files being generated. Ensure that this is read-only, because whoever is reading from that, you don't want that agent to be running as root. All kinds of bad things happen when you give root permissions to your applications, right? But the complexity that it introduces. When you get into a Kubernetes world, the biggest thing is now you're dealing with logs that are spread across applications. You can have an application that has respawned itself with a new pod ID, a container ID, and everything on that particular machine. Now, how do you tie back the two logs? Because your application died because it ran into an error situation and it respawned as something else. Now, in order to do any sort of meaningful troubleshooting, you have to tie back those two events as to why it died and then what happened after when it respawned. So that complexity, how do we solve for those things? And then we also have applications that are scheduled on different hosts. So your same application now would be spread across multiple hosts in Kubernetes. This is what you want Kubernetes to do, and because it is auto-scaling or whatever the case might be. But how do we solve for this kind of complexity? Thankfully, there's very straightforward solutions that are available out of the box if you're played around with it. So I'm going to go a little bit into those things, and there's not the entirety of the solutions that are there. Some of the big ones that are left out are commercial solutions. Nothing wrong with them. In fact, we love them, and I've used them personally as well. It's just that these are some of the things that are open source and available for you to use and play around with right out of the box. One of the big things that I love is Fluent Bit. It just got promoted from the Cloud Native Foundation. It graduated from the CNCF. And the best part about Fluent Bit is the community around it. So Fluent Bit, what it does is it runs an agent on your machine, and if you point it to where your logs are, it is able to read those logs. It is able to apply a lot of logic on top of it, like enhancing the logs with the context that we were talking about. And also, it could do many other things like filter out extraneous logs so that you reduce the noise out of it. You can also munch together exceptions, which are multi-line exceptions. So it understands there's plugins to do those kind of things as well. And then it can also send it out to different end systems. Like if you're digesting your logs through Splunk, through Elasticsearch, through Datadog, or anything the end solution might be, it has the ability to do that. One of the big things about Fluent Bit, though, and I'm not shy about talking that as well, is it's a memory hog. It runs on Ruby, and it has been made efficient over time, but it still takes up a lot of memory. And you have to be conscious of that. You have to make sure that on your host, you use a different kind of memory allocation library. So usually you use gemalloc instead of the regular memory allocation that Linux uses for running Fluent, so that it gives back the memory that it takes up in an efficient way. But because of that, the Fluent community has been working on making it native application library through Fluent Bit. This is still a kind of, I would say that this is a parallel effort from Fluent itself, but at the same time, this has been rewritten from scratch, where it is now a native application that is running a native executable that is running on your machines, and it does much better use of your memory, but the plugins are not there yet on the same level as what you would find for Fluent. So Fluent, it has about 3,000 plus plugins, I would believe, in the community, and this is about 30 or 40 of them. So if you still use a lot of the plugins that you were used to using in Fluent, prepare for that transition, but it may not be something that you would be able to do right away. Another thing that has come along from the Elastic community was Beats. So Beats is kind of a replacement for Logstash, and I might be completely off on that, but one of the good things about Beats is, again, it goes by the same model of Fluent versus Fluent Bit. Is Beats is very modular and it is very efficient, so it kind of blends into the background when it's running and it's collecting the logs out. And you have different kinds of beats in order to get the audits. You can do a lot of other things as well, like your files, your metrics, your packets, and every other kind of modules that you could use in there, right? But we've talked about different solutions again, where we are talking about collecting the logs and then shipping it out to a log aggregator so that you could do some meaningful analysis on that. But how about the context? We talked about context earlier. How do we get the context into each and every log that we put in there? Right, but before we go there, any questions that I can answer before we dive into that? One in the back. All right, so let's keep going, and feel free to set up a session in the during the open spaces as well if you're interested in digging deep into this, and we can go over them. Context. Again, Aaron touched a little bit about this, but here's some of the context things that you would want to add to each and every log metric that you're collecting, right? You want to know what that particular pod or container metadata is, like your pod name, pod ID, namespace, the host that it was running on, and this is not an exhaustive list, but these in particular are really important, right? This would describe things like if you have a new release, or if you were doing a blue-green deployment or a canary deployment, the application name and everything else would stay the same, and the container name might still be the same, but then as part of your labels, you can label it as blue versus green, and then you would be able to see the context that your new release is generating more errors than your previous release, and you can catch it even before you make that blue-green release go further along and take over, right? So that's one of the most important things that you would want to do, is make sure that all the labels that you would associate with in the Kubernetes context flow down to your logs as well. So everything that you would label in a deployment or a daemon set, you want to flow them along. And the same with annotations as well, because some of the metadata might be hidden in some annotations. So one of the things that, all the products that we talked about have native ways to get this done. In Fluent, there is a Kubernetes plugin, Kubernetes Metadata Filter. So it ensures that it talks to the API server based on what the pod name and the pod ID and all of that are, and it gets you this labels and the annotation metadata. It then adds that to your log, each and every log metric that log event that you're generating, and then sends it out to the log aggregator. It might be, the aggregator might be Splunk, it might be a database that you're collecting all the events in, or Elasticsearch, right? And then Beats has the same kind of thing. I think it's called service module or something like that, and I might be off on that, but it has a native way of doing the Kubernetes metadata as well, where you can ensure that it tags that data on top of every event that you collect. And for Fluent Bit, it is actually a built-in filter called Kubernetes Filter, because the Fluent Bit rewrite was done a lot in the Kubernetes context. So this is something that is available as part of the product itself without you putting in a new plugin or embedding that new plugin into your repository or your container that is running. And that's something that I wanted to touch upon as well. But how do you run Beats, FluentD, and Fluent Bit on your infrastructure? So if you have a Kubernetes cluster, per se, how do you run that? So there's two ways of doing that. One is you can run it as a container itself. So it's almost running as a daemon set or an agent that is running on each and every host that is part of the Kubernetes cluster. And the other way of doing that is to run it as a standalone agent on the systems themselves. And there's pros and cons to both of them. One of the pros about this is now you don't have to ensure that you bake this into your machine images when you deploy it onto your worker nodes. So every machine image comes, you don't have to ensure that every machine image is pruned for the right versions, the patches and everything for putting in these agents in there, right? So if you do it as a Kubernetes daemon set, you can just deploy it as a Kubernetes service itself, and it would go ahead and make sure that every host that is part of it gets one of those deployments as a container. Now, the other part of it is about the con for a deployment like that as part of a Kubernetes daemon set is it cannot observe itself. What that means is Kubernetes runs on top of container, the container solution, the CRI, the container runtime, and then there's Kubelet as well that is doing a lot of the scheduling for those particular pods. So if there's something wrong with either the Docker daemon or your kubelet itself, it cannot observe them because most likely it is causing problems with running containers on that particular host. So you would want to then, if you want to observe anything below that stack, you would want to run it as an agent. And the pro about running it as an agent is now you can not just get the Kubernetes context of all Kubernetes logs, but you can get all the systemd logs. You can get a lot of the other logs of applications that are running not as containers on top of your infrastructure as well. So that's one thing. But you have to, the con in there is you have to ensure that those agents are baked in, and you have a config management way of pushing it to each and every node on your infrastructure, and they're configured to now send it to the right the right endpoints and so forth, right? So that's pretty much what I wanted to cover in there. Again, wanted to take a pause, see if anyone has any questions or interest in going further into these topics, right? All right. Just recap of everything that we talked about. One of the big things is events are not just logging events. These could be events that are doing your traces, your open tracing and such. And you could use a lot of the solutions that are in here to repurpose them for doing a lot of those metrics and open traces as well. The other part of it is there's quite a few open solutions that you could get started off on, like your Elastic stack with FluentD in the middle, And then there's Splunk, there's Haystack. If you've taken a look at that, especially Haystack is something that I've been looking at very recently. This is from the team from Expedia. This is an open source product which kind of clubs together Prometheus monitoring, metrics collection, and it has a way to do tracing as well and puts everything together in a single pane of glass. So this is something that is really useful to take a look at, and it also goes to the details of what is the architecture behind it. So if you really want to write a solution on your own or architect a solution on your own, you can use those building blocks and then create something and adapt it to your own organization. That's about it. So thank you so much for your time. And as I said, if you feel that you want to do a deep dive, let's do that through the open spaces. All right?